It's a tough question, especially if you've never seen anything like this before. And you do see things like this on math challenges sometimes, but yeah, definitely not typical. We're trying to find the shortest distance from P to the midpoint of OR. I'm going to label it M, but we have to go along the outer surface. We can't just say, right, I'm going to go from here to here because that would be on the inside. Got to move along the outside. So it's quite hard to just visualize right from here which way to go. And so the key really is to imagine unfolding the shape into a net. And here's one such net that we could draw. We could take this square base and then just imagine unfolding all of the triangles out. So I just want to reiterate, this is not the only route, but one route would then to go from P to M would be to go along this straight line. And it will be equivalent, it'll be the equivalent, it wouldn't be a straight line on the actual shape, but it'll be the same length. So we're going, actually, we're going to end up going through the midpoint of SR, I think, and then to M. So if I try and draw this, it's going to go down there and then back up. Okay, now that is not the only way we could go, because we could potentially avoid the square. But it's quite hard from this net to see that. So here is a different net. What I've done here is again, I've unfolded most of the triangles except the PSO. I've connected it to OSR. If you imagine them bringing it up and bringing that one round, it would still form a net. You can draw more than one net. So now I'm going again from P to M, but M is going to be here. And I can avoid the square and go directly like this. I got to be honest, when I did this question, I actually went straight for this one. Didn't even think about using the square, so I kind of lucked out. It ends up being the shortest path, and if you draw your diagram reasonably accurately, you can see it looks quite a bit shorter. So, well, I'm definitely going to focus on finding this length here. So to visualize it a little bit better, I'm going to rotate the net now, and there we go. So now I've got these are going to be horizontal lines. And if I want to find the length PM, I can create a right angled triangle. Let me try that again. And I can use Pythagoras. So I know I'm going halfway down on the triangles. First thing to do is to work out the height of the triangle. We know that it's 20 by 20. Let's use Pythagoras. So split the triangle into two, then this will be 10. And this length will be 20 squared minus 10 squared, square rooted, which is the square root of 400 minus 100. That's 300, which becomes 10 root 3. And what that means is that the height here on my triangle is going to be 5 root 3. It's going to be half of 10 root 3. Brilliant. And then one other thing to think about is the fact that, okay, M is halfway along OR, so it's a half of the height, and it's actually going to mean that this length here is going to be 10. You can split an equilateral triangle, which is what these are, into 4 equilateral triangles. So what I've done now is if I just draw that out again, yeah, this one here is going to be a 10 by 10 by 10 equilateral triangle. And the reason that I'm talking about that is that now if I go halfway down here, then this length will be a half of 10. It's going to be 5. And remember, we've got 20 for this length. So my overall length of my right angle triangle is going to be 25. So I've worked out the height of the little green triangle, 5 root 3. I've worked out the base is going to be 10. I've halved it to give me 5. And then I can see this purple triangle that I'm now shading in. It has a hypotenuse of PM. That's the one I want to find, that shortest route. Height of 5 root 3 and base of 25. So PM is going to equal 25 squared, that horizontal base, plus 5 root 3 squared, all square rooted, which is 625 plus 5 times 5 is 25, root 3 squared is 3, 75 square rooted, which is the square root of 700, or 10 root 7. That ends up being the shortest distance along the outer surface. Just for completeness, let me find the other length. So here we're going to end up going, I can draw another right angled triangle. And remember, we can create a little triangle here. We know that base is 10, which means this here and the other side will be 5. So that will be 15. And then I've got 20 from Q to R, and I'm adding half of the height. So it will be 20 plus 5 root 3. Okay, and then PM this way, or I'm going to deal with PM squared to start with, will be 15 squared plus 20 plus 5 root 3 all squared. So I'm not squaring 25, but I'm squaring two fairly large quantities here. This is 225. Expand that double bracket. 400 plus, what will I get? I will get 200 root 3 plus, again, that 5 root 3 squared, which gives me 75. Add up the non-surds, that's going to get me to 700 plus 200 root 3. And if I find PM, I take the square root, you can see I've got the square root of 700, but then I'm adding something on. So this is necessarily going to be bigger than the square root of 700. So we don't need to go any further. We can see that the other one is going to be shorter. But if you wanted, if you weren't sure, then you could look into that. Now, is that answer on there? I think it might be, which is, if I take the factor of 10 out, then yeah, it's that E. So you could easily be mistaken and go for that one. But yeah, I didn't draw the blue one on in the end. Let me just do that. So, okay, just to summarize then, we're trying to find the shortest distance. The key is drawing a net, but not just a single net, because then you might think it's got to be that one there. Okay, think about it carefully. What could be the quickest path? And actually going over the triangle ends up being quicker. So if I draw it on my original diagram, I was going from P through OS, but nearer to O, and then background. So that is the route that was slightly quicker going along the triangles. But we worked out both. I mean, I worked out the blue one to start with. It looked shorter on the net. Just, thought about, used Pythagoras multiple times, basically. Got root 700. Did the same with the red one, saw that it was bigger. So well done on the efforts on this question. Lots to take away from it, I think.